I'm Veronica Lopez. I work in DigitalOcean in New York, although this talk has nothing to do with my work there, but it's worth noting what I do for a living. I'm a software engineer there. I don't work with Elixir right now in my day job, unfortunately, because the things that I do right now make more sense in Go, and also the type of jobs that I like and the impact that I like to have usually are not compatible with Elixir, at least in my side of the world. I understand that on this side, Elixir is like suitable for more interesting projects, which is one of the reasons why I love being here. But in America, it's not like that. But that said, okay, so this is like brief table of contents. There is no like a specific structure, but we will cover these points today with the introduction of what is cloud native, which is not just things in the cloud, but what it actually means. Cloud native today, how it looks like, and also the future, cloud native and the Beam. All of this will make sense as I go forward with the talk. Okay, so who am I? A little bit of why I'm here. I used to be a physicist, which is actually one of the reasons why I ended up in Elixir and the Beam community, because I understand that there are a lot of physicists, like the late Joe Erlang, that used to be a physicist too, or had a background in physics. Functional languages are very popular among scientists. My first programming language was Fortran. I didn't know it was a cool thing to have. It was just like what was available at the moment for computer simulations. And then I transitioned into computer science because I found out that I was way better at coding than at research. I also didn't have the kind of patience to be like an academic person with grants and all that. As I sort of said, I work mostly with Go and Elixir, even though I don't do Elixir in my day job. I have been involved in some projects. I have done Elixir full-time in the past. And I have a personal project from my former graduate studies that is also made mostly with the Beam, with Erlang and Elixir. Oh, also like warning. Since Elixir is the language that I have the most experience with on the Beam, many times I will mention Elixir, but for the context, it is interchangeable for any Beam language. So when I say Elixir, it's the Beam. Also, well, right now I'm in DigitalOcean, but I used to work at CoreOS. It was later acquired by Red Hat. So a lot of containers, a lot of Docker, a lot of all those buzzwords. So ultimately, that brought me into the cloud native area. And since I have both worlds, like I like to think I have the best of both worlds. I love Elixir, the Beam. The structure, everything makes sense with my mind structure. So I have been fortunate enough to collaborate in the Kubernetes space as well, which is, in my opinion, and in many people's opinions, like a copy of what the Beam is trying to do, or what the Beam excels at, Kubernetes tries to do. So, well, I will tell you a little bit more about this part in a second, but well. First, some definitions. So cloud native is not just having things in the cloud, as I said. The cloud native area, and as a brand, let's say, is about how applications are created and deployed, not about where. Ideally, it integrates 4 disciplines or 4 concepts, like DevOps, continuous delivery, microservices, and or containers. And in this container space is also Kubernetes. Okay, so this is cloud native development, how it should look like. So as I said, DevOps, continuous delivery, microservices, and containers. So DevOps as a culture, not as a job description. Like this is the ideal thing to do. There are many job postings nowadays that says like, we are looking for a senior DevOps or we're looking for a junior DevOps. And I totally understand the goal of that. But the intention of DevOps is not having someone doing DevOps. It's like a culture. It means that the person deploying the stuff doesn't necessarily have to be the person who wrote the stuff, but they have to be in constant sync, collaborating all the time, particularly because continuous delivery is expected. So if the person delivering the stuff doesn't know the goal of the person who wrote it, and the same otherwise, it is very difficult to tackle the goals that you want to tackle. And well, then the continuous delivery guarantees that all types of tests are passing, allows different teams to contribute in a consistent way. This means if we have an organization with 20 different teams, such like, for example, DigitalOcean, and we all contribute to the same monorepo with different types of code and with different priorities in mind, having continuous delivery rules ensures that nobody breaks each other's code because we have different rules or different expectations or even different styles or even bad code compared to our peers, right? So that is what continuous delivery guarantees. And then we have the microservices and containers. Of course, Docker and Kubernetes enable easy usage of other cloud-native ecosystem tools, as we're going to see, or if you're familiar with this already. By the way, who here works with cloud-native tools? Or nice. Let's say Docker. With Docker, yeah, everyone. How about Kubernetes? And how many of you who work with Kubernetes actually like Kubernetes? Compared to the Beam. Okay. So this is cloud-native development, how it actually looks like. So DevOps, companies are looking for DevOps with 15 years of experience, which are usually interchangeable for SREs or even sysadmins, very powerful sysadmins. Again, there's nothing inherently wrong with looking for a DevOps, but it's not the goal of the whole culture. It should be a culture, not a job description. Then on the continuous delivery side, I have never done this myself, but people triggering jobs manually because the test didn't pass and they need to ship regardless. I don't know how it works in this side of the world, but in America, it's America, so you have to ship. You have customers, you promise deliveries, you have deadlines. So it doesn't matter if everything is broken, you have deadlines. So people do terrible things to make deadlines work. One of those terrible things is that. So then the point of having continuous delivery, continuous integration, and all this tooling that we have to ensure that is basically nonsense. And then the microservices and containers, well, Docker and Kubernetes were invented to help us have better lives as developers, but many times they try to reinvent the wheel, and sometimes they're very insecure compared to other old school tools, right? So with this, I just want to clarify that cloud native itself is not bad or good. It's it was born with very good intentions, but there are many ways in which people don't follow the rules. Okay, so, but what does the Beam have to do with this anyway? I'll give you 30 seconds to read this. Any sufficiently complicated microservices deployment contains an ad hoc, informally specified bug-ridden implementation of half of Erlang, which I don't know your opinion, but I think this is very true. So Andrew is my friend, and I actually this tweet is very old in internet years. I didn't see when he tweeted this live, but we were recording a podcast some months ago, and I told him something similar to this idea, although I am not very good at putting my thoughts together in very small, short sentences. So I sort of shared my feelings about Kubernetes, specifically Kubernetes, and how I felt about Erlang and Elixir, and how I thought that they sort of reinvented the wheel. And he told me about this tweet, and I was like, oh my God, this is so, so true. And then like Robert Bearding also endorsed this, and then talking to Francesco, it was basically the same feeling, and I was like, okay, I'm good. I'm not like a hater or anything like that, or I am, but with a reason. So a little bit of background for having this sort of thoughts. So when I started working at CoreOS, I was hired as a distributed systems engineer, whatever that meant. But I was never told that I would be working on Kubernetes or Kubernetes distribution, or enterprise Kubernetes distribution back then. It was sort of like a coincidence, a very bad coincidence, but now I'm grateful for it. So I didn't know anything about it. And so I started working on it, and I was like, this is not real distributed systems. This is like a layer on top of distributed systems, or what I thought it was like. And so I started like recognizing concepts such as fault tolerance, resilience, nodes, failing nodes. I don't know, all of that, all of the concepts that we already have in the Beam and in distributed systems in general, but adopted by Kubernetes with different language, like pods and clusters. Like the word cluster, it used to sound like very impressive for me in the past, like we have a cluster full of things. And in Kubernetes, it's just like 3 little pods. So, well, things like that got adopted by Kubernetes, and I was like, this looks very familiar to me, like with, as I said, to the Beam. Yet, it is very like flaky. Again, I'm not trashing. I am just like comparing like the ecosystems, because that's my experience on both sides. And in Kubernetes, since it is a very hot project, you have to deliver. And I am not saying this now in the context of like, it's America and you have to deliver. No, but like there's so much money at stake. There is so much interest at stake that you have to deliver. And also there are very smart people involved. But I'll come to this point back like in 2 seconds. So the current status, so much tooling. CNCF, if you don't know what CNCF is like the Cloud Native Foundation that fosters a ton of projects that contribute in one way or another to the Cloud Native ecosystem. Just to start, for example, independent Kubernetes distributions. Check out Typhoon. It was made by one of my friends, and it's super, super cool. Monitoring tools like Prometheus that you might be very familiar with, which is the most famous one. Then container registries. There are so many container registries. I literally thought there were only 2, because like the Docker one and the CoreOS one that I used to work on. But the point is that there are many, many tools. And you would think like by the end of the day, it's like the more the merrier, right? Well, no. No, because like it is awesome to have options, but once you have like an ecosystem full of tooling that does the same, and just adds layers of complexity, it is wrong, like inherently wrong. Like why would you want like additional layers of complexity for something that can be done already by some other programming language or some other ecosystem, or Kubernetes alone? But let me tell you like the secret. If you're using Kubernetes in production, there are like high odds that you will be using a lot of tooling that is not necessary. Like probably a blog post, probably a company told you that it is necessary that you use their tool, like their additional tool. And it probably is making your life easier, but it is not necessary. Like the only necessary thing you need from Kubernetes is like Kubernetes itself, like plain vanilla. But then you start adding resources and adding them because they will make your life easier. But at some point, you just wanted to deploy your website. and then you have like all of this like circus around it. So as I said, most of these tools, no, not this, tools are already things that the Beam has, but they're like sort of reinventing the wheel. Now, there's a very important part that I must mention. So Kubernetes was developed and is still developed by amazing people, and I'm still part of like that community. Not only the community, like as of right now, I'm working on the CI team that basically ensures that everything before a release is good. Like there are no bugs, there are no failures, which sounds like very easy, but it is not, given that there are many other teams like trying to deliver. And so as a distributed system that it is, there are some bugs that a team might think they're like minor, but once we see, like on my team, or teams like mine, we see the whole picture, you might see that that minor bug is actually blocking someone else's job. So our job is to tell them like, oh, no, like you should actually fix this. Otherwise, we won't have any releases, and we should deliver stuff like that. Or sometimes it's the other way around. Like people are like freaking out over like a failure, and we're like, okay, no, we're fine, and stuff like that. So what I'm trying to say is like, the reason why this happens is not because people are ignorant or because they're bad software engineers or because they don't want to. They're like very, very smart people, but it has come to my attention that a lot of times when I talk, I'm always the person talking about Elixir in Go context, in Kubernetes context. And people are like, yeah, whatever. But every once in a while, one of them would actually be curious. Like I would spark their curiosity, and they would be like, okay, tell me everything about this Elixir thing that you always talk about. And I started by telling them like fault tolerance, blah, blah, blah. And they're like, oh, really? And they're like genuinely surprised. Like people that I consider like even mentors or at a more senior level than I am are genuinely surprised. And this doesn't mean that they're not as senior as I thought or stuff like that, but like it is almost like a philosophical thing for me, because these are people with 20 years of experience, 25 years of experience in the software industry, yet they are not familiar with this concept at all. Like they know that they exist, like they know that fault tolerance exists, but they don't know that there is a tool that already handles that since like long ago. So they're basically surprised. And so one of the reasons or one of the luxuries that I have right now and why I'm still contributing in the Kubernetes space is because I have the opportunity at a very little scale where I can contribute with my knowledge of the Beam, and I can tell them like, no, this actually gets solved like this, and it's very interesting. Actually, if you would like to contribute, like it is open source, you can contribute in many, many ways without the code, but with your knowledge on the Beam to try to make Kubernetes better as a distributed system or as people trying to build, as a tool for people trying to build distributed systems. So that is actually very fun. So if you're interested, let me know. Okay, so one of the, by the way, I'm using Kubernetes as like the poster child of the cloud native ecosystem, but you can mostly interchange Kubernetes for mostly any other project in the cloud native catalog, except for probably Prometheus, I think. Because I think that Prometheus is like one of the most solid pieces of software out there. But other than that, everything else is still in constant development, which is not bad inherently, but compared to, for example, the Beam, that or Elixir is like, if it's not broken, then you don't fix it, right? And Kubernetes, I can tell you, it goes through different release cycles, like at least 4 major release cycles a year, and in between, almost infinite. So for something that already exists, it's a little bit difficult to handle. Okay, but does it make any sense to use Kubernetes if I already use Elixir? So among the people that raise their hands, Those of you who already use Kubernetes, do you use it with Elixir or any other Beam language? Oh, wow. OK, yeah, that was significantly less. OK, and I can see why. So there are many features that actually overlap. And people ask me this a lot. And on the internet, there are many tutorials. I don't know if you have seen them on how to do the thing, how to implement Elixir with Kubernetes or the other way around, or how to integrate Prometheus or how to integrate any other CNCF tool. But nobody tells you why. There's just this one blog post that is like recent, very recent, from October from this year that Jose Valim finally published, in which he actually goes through at a very high level, which is great for everyone to understand, on what is the difference, what is the actual difference between like the Beam at some level and things like Kubernetes at another level. What sort of concepts overlap and what sort of concepts just overlap by definition, but not at implementation. And where does it make sense and where it doesn't make sense. What I always try to tell people, yeah, why don't we have both? It's like, let's go back to the basics. Things like Docker and Kubernetes were meant to be used just as the delivery phase of things to make our lives easier. Like later people ended up using Docker for black magic things, but the original intent was to do like very simple stuff, but very simple but useful stuff. Like for example, packaging all your environment in a single container so that it can be easily deployed anywhere without having to install all your stack in a server. Stuff like that, very practical things and now people use Docker for all things possible, which is not inherently wrong, but sometimes it adds a lot of complexity to a system for no reason. So when people ask me, my short answer is like, yes, you can use both, but only if you use them, if you use Kubernetes for what it was meant for, like orchestrating your Docker containers, just on the delivery phase. Because one mistake, and I personally think it's a mistake, is for people to use Kubernetes, like tools like Kubernetes or the cloud ecosystem as their main tool for resilience. Like basically their code is not that good on that side. So they're like, OK, let's use Kubernetes and we'll be fine. Sometimes it works, but sometimes it doesn't. Then again, let me remind you that Kubernetes is still a work in progress. So you don't want to give it that much of a responsibility. You can use it for helpful purposes, but not for entirely responsible purposes. OK, so a really nice way that Jose put it was, this is a quote from his blog post. So Kubernetes provides fault tolerance within the cluster, while Erlang Elixir provide it within your application. So going back to the why not both, this is a really good explanation. Like you can have all your resilience, your fault tolerance, your concepts that overlap by definition on both sides. So you can have them both at your code, at your application level, and then you can have them at your infrastructure level. So that's very nice, actually. In that blog post, it is not, I don't have the link here, but if you follow me on Twitter, I will post it. And it is also not very hard to find. You just look for Jose Valim in Kubernetes orchestration, and you'll find it. So in this same blog post, he goes through like a very high-level example of a database connection and where does it make sense. How would it fail from the Kubernetes perspective, and how it would fail from the application perspective. So I don't like going through that sort of detail because, as I said, there are many examples on the internet, and I believe, or at least for me, it is easier and way more understandable to go through like by myself reading them rather than looking at a talk. So pros and cons of Kubernetes or the cloud native tools in this context. So on the top part, it is the good things, the pros, and on the lower level are the cons. So on the pros is language agnostic, which is like, okay, so I can make my system resilient. It doesn't matter if it's a website, a distributed system, a basic system, a mobile app, or if it is written in Erlang, or in Java, or in JavaScript, or in Fortran. Like, I just containerize it, and it works. And it just has all this amazing distributed systems perks because I use a single tool. Yeah, no. So by definition, it should work like that, but it doesn't for all the reasons that I already enlisted. And then the second good thing is that this might sound very, very silly, but it's actually very good. For those working with this type of tools, this will probably resonate with you. Like, there are lots of resources and providers around. So basically, if you have any bug or any situation in your implementation, since all of these tools are becoming more and more popular, chances are that you will find a very useful blog post or a very popular implementation that will help you. Versus other types of tools that are like a little bit more obscure, like Elixir. Or I know that here not, but in America sometimes it is. So like a lot of people usually complain to me that they couldn't find enough resources, that they would find the same post by Jose, or the same blog post by, I don't know, by someone else. So this matters a lot. Usually when people ask me about orchestration tools, for example, the difference between them, like should I use Mesos, or should I use Kubernetes, or should I use Docker Swarm? I tell them, well, it's basically the same for the purposes, the external purposes, but I would just pick Kubernetes. If you have to, then I would just pick Kubernetes, because that's the more popular one, and the list of resources is almost infinite. But if you don't have to, please, by all means, don't use Kubernetes. Because, like, why would you add additional complexity just for the sake of it? Okay, and then on the cons, it's like once you add Kubernetes to your, like, as a cherry on top of your cake, it's still a lot of manual tweaking. Why? Because it's still a work in progress. Like, you would find many providers that will sell you their enterprise Kubernetes distribution. And I know this because I used to work for one. And some of them started, their business started not writing any software, but their core business was to help you use Kubernetes. Like that was their main business, to send someone to actually install you the thing. Then as things progressed a little bit, the next milestone in that ecosystem was, okay, I'm selling you the installer. A wizard, let's say, a piece of software that was nothing but a wizard where you can click next, but the software was the same that you would install from the website. With nothing on top. Then companies started putting additional layers of security, additional networking capabilities, stuff like that. But essentially, what most of them sell are the experience. How all of that manual tweaking that you don't have to do anymore. So that is what it is, and it's not actually bad, because when you do it manually, it's very painful, and you have to be sort of an expert, which is against the point of the original philosophy, in which all these tools were born to help us. And you might be a mobile developer, a web developer, or even a systems developer, and you don't want to be an expert on every single one of these tools. So yeah, that's a big con, and I'm sorry for just talking about that. And The second, and this is very, very, very controversial, but I say this with all my heart, and I am not the only one who thinks this. It's like, these tools are usually not developed by distributed systems experts. They're, as I said, they're developed by experts, by people who have lots and lots of combined years of experience in the industry. Yet, you can see that they are not distributed systems experts, and that shows in the code, not just in the opinions. Yeah, as I said, this can translate into a very good opportunity for people like possibly you to contribute into a huge project that has a lot of impact with your knowledge and telling people like, hey, maybe like, okay, I understand the reasons behind this, where you're coming from, but maybe you could use this other protocol, stuff like that. Because there's a very important, a very significant part of Kubernetes developers for which distributed systems, their first entrance or their first experience, no matter how many years of experience they have as a whole, but their first experience with distributed systems is Kubernetes. Like, people who work in this ecosystem, in the cloud-native ecosystem, like to think of themselves as distributed systems engineers, and they are not. So that's like a huge, I mean, compared to distributed systems people, like from our era, you know, like, I don't know, I can name Christopher, Michael, John, or Jose Valim, like names that you're maybe like very familiar with, that are like actually working on those things. And it's not a coincidence that most of us have the same opinion, coming from different types of experiences. Like, we didn't just sit down to have beer one day to trash on the cloud native. No, it was just like, while trying to, like, we're looking at how it looked like, we all came to very similar conclusions, so you can tell. Okay, so the goal. Talking, again, to many other people, like smarter people than me, with many different kinds of experiences, we all came to the same conclusion. And a little bit over a month ago, Francesco and I were in Colombia, and he gave an amazing talk that you should definitely check out. And his point was sort of this, like, the goal. The future looks like, our vision is that at some point people will be able to use Kubernetes, or what Kubernetes is meant for, without knowing they are using it. How? Francesco has some answers, but we have the attitude and the knowledge to do it. No, but seriously, it is like another, just what I said, like people coming from different experiences, converging on the same thought, on the same conclusion. One thing that I forgot to verbally mention, but I have it here on the pros, is the second one, that we also have tons of good jobs on this ecosystem, which, I mean, is great. Like, who doesn't like money and impact and stuff like that? So if you're good at Kubernetes, but really good, and coming from a distributed systems background will make you like ideally good or decently good for Kubernetes, will give you a very decent job. You will just have to be very patient, but it pays off, and it's really fun because you get to solve like a lot of problems from the raw state, not just like making things pretty, but making very ugly things very pretty, potentially. So, yeah, so to sort of go a little bit deeper on this concept, so again, our vision is that at some point people will be able to use these tools without knowing they're actually using them. Let's go a little bit back to the point where I said that companies, their selling point is making the Kubernetes experience easier for people. They're not actually selling you a lot of extra things, and the extra layers that they put on top are basically just like sprinkles in the context of software. I'm not saying they're not useful, not at all. The reason actually why there are so many distributions out there is because each and every single one of them focus on different stuff, just like Linux. Remember, like for those of you who use Linux, back in the day, right now we have some sort of consistency, but back in the day, like Arch Linux was for some sort of users, Ubuntu was for the people that wanted like the easy experience, Debian was like for the hackers, and I don't know, stuff like that, for people that wanted to tweak it more and more, and stuff like that. So think of the Kubernetes or cloud native distributions of stuff in like similar terms. But then again, like who wants to tweak stuff that was meant to be made or created to make our lives easier, sorry. So yeah, the goal is this, like to create some sort of layer on top of everything where we can have these capabilities, even if we're not using the beam, even if like to really be like language agnostic. Some sort of tool, some sort of layer in which all of this can be used without the user knowing. That should be like the goal in terms of usability and in terms of helping people. So yeah, I don't know. I think I ran a little bit quick, but I sort of wanted to go deeper into one of these concepts. But well, anyway, if you have any questions, let me know here or on Twitter. I am very responsive on Twitter, and even though this is not a DigitalOcean sponsored talk, if you want to join us, don't hesitate, you can ask me, and that's it.